Hey guys, this is a video about how to do matrices, matrix addition and subtraction, and matrix multiplication questions. I don't think I've ever seen these questions on the SAT, but the ACT often likes to ask them. So here goes. A matrix, by the way, is kind of a square looking thing, and they're used to hold data. I didn't have questions like this when I was in high school. But I think in the last couple of decades, as more and more data storage on the internet becomes so important to everyday life, matrix questions have emerged. I could be wrong on this, but that's what I've gathered so far. And basically how it works is like when when Netflix or Amazon suggest things to you, they keep all your past choices in a matrix of all the decisions you've made, and basically they will compare, let's say, all the movies you've watched on Netflix to other users with a similar matrix, and then whatever choices they've made that you haven't are what they're going to recommend to you. So maybe that makes it mildly more interesting to know a little bit of what the point of matrices is. And we'll start with matrix addition and subtraction, which are very, very easy questions. So you'll see one, let's see, I'll find a question here, like number 5. And the big thing to know with matrix addition and subtraction is that the only way you can ever add or subtract two matrices is if they have the exact same dimensions. So in question 5 here, they're both 2 by 2. And the reason that's so important is so that you can add or subtract the numbers in the exact same places in the matrices. So we'll do this one here on the whiteboard to the right there. And all we're going to do is take that top left number, and in this case it's addition, so we're going to add it to the other matrices top left number. So 9 plus -6 is going to be 3. And then we could do the top right numbers. We've got 8 plus 6 is going to be 14. And you'll notice already only 2 of the answers even have 3 and 14 as their top numbers. So C, D, and E are already wrong, and you know that. And usually with these matrix questions, you only have to figure out like 2 of the numbers, and you already have the answer. In this case, it looks like they want us, we'll have to do a third one. We'll do the bottom left number, which will be -4 plus 5, which is 1. And yeah, only A has 3, 14, and 1. And we don't even have to do that last number in the bottom right. We already know the answer. So that is matrix addition. If it were subtraction, it would be all the same steps. We'd just be subtracting top left number from top left number, top right number from top right number. And so long as your two matrices have the exact same dimensions, you can do it. You can do matrix addition or subtraction. So let's just say, if you look over at the whiteboard on the right, the matrix in the top left, let's say it was 2 by 3. Then, 2 by 3, then the matrix on the right would have to be 2 by 3 as well to be able to add or subtract them. So those two matrices have the exact same dimensions, 2 by 3. So we can subtract them. If the second matrix was like what I'm about to show you, you might think for a second that you might be able to add or subtract them, but you can't. First matrix is 2 by 3, and the second matrix is 3 by 2. So the two matrices have to be absolutely exactly the same to be able to add or subtract them. All right, so that is matrix addition and subtraction. You can see question 8 here would be very easy to do, knowing what you know now. And the next thing to show you is, what do you do when there's a number in front of the matrix? The answer is you multiply it. So I'll show you. Question 10 here on the whiteboard. We'll just look at that first matrix right there. 2, 1, 3, 2, 4. All you do here is multiply all the numbers by 2. So it becomes 2, 6, 4, 8. And obviously you do that for the second matrix in this question. Six, -3, 3, and -6. And then we would add these two matrices right here. And the reason that we can add these two matrices, yes, you guessed it, is because they have the exact same dimensions. They're both 2 by 2, so we can add or subtract them. Next thing we should show you is what to do when you have a determinant. Determinant shows up a good amount on these questions, and you just have to memorize what it is. I don't actually know what the determinant is in real life, but I know enough to get these questions correct, so that's what I'll pass on to you. You'll see 52 here. Determinants, as far as I've ever seen them, they only take place in two matrices that are 2 by 2. And it's basically, and half the time they tell you what the determinant is. Just like this question tells you, it's AD minus BC. In other words, it's multiplying top left and bottom right and subtracting the product of bottom left and top right. Like you're multiplying diagonally across and then subtracting. So in this matrix that we've got right here on the whiteboard here, it would be 4 minus 6 equals 2. Sorry, -2. The determinant there is -2. In question 52 here, our determinant is going to be -b minus a. Sorry, whoops. -b times. -b times a, which would be -ba. Top left times bottom right. And then -d times -c, which is plus dc. And so if our answer is -ba plus dc, it's going to be answer choice Did I do this wrong? No, I'm double checking my work. So -b times a, so it should definitely be -ba. I would get rid of F, G, and H because they do not have -ba. And then, and then d times -d times -c, which is positive dc. Oh. Got it. So I did my multiplication there wrong. So that's why its number is 52. It's a little bit tricky. -d. So if we do bottom left times top right, -d times -c, that would be positive dc. But the determinant formula is AD minus BC. So they're just getting you confused with plus signs and minus signs and the letters. But yeah, so this one is going to end up K, -BA, it's -DC. All right, to get out of all this unnecessary complexity, just remember determinant is AD minus BC. It's always in a 2 by 2 matrix. And you're just multiplying the numbers that are diagonally from each other and then subtracting. So AD minus BC, and memorize that. Write that down and memorize it, and then you'll always get these questions correct. So 55 is a pretty easy determinant question, much easier one than the one we just did. And so that one is just going to be 8 times -2, -16 minus negative 5 times 3, which is negative 15. So that'll actually become negative 16 plus 15, which is negative 1. So the answer is going to be C. Okay. 57, another determinant question. All you got to know, and you'll see they often tell you, determinant equals AD minus BC. Top left, bottom right, multiplied, minus bottom left, top right, multiplied. Okay. Lastly, let's get to matrix multiplication. It's a little bit more complicated. The big thing to know with matrix multiplication is that in order to be able to multiply two matrices, the number of columns in the first matrix must equal the number of rows in the second matrix. Columns in the first matrix has to equal the number of rows in the second matrix. So this is what question 48 is about here. They say which of the following matrix products is undefined. Let's go through this one by one. So answer choice F says WX. All right, so W times X. W, number of columns in the first matrix. It's not letting me draw. Let's try one more time. Oh well. So let's look at W. Columns in the first matrix. It has W as the first matrix there has 2 columns. Has to equal the number of rows in the second matrix. X has 2 rows. So that product will not be undefined. You can multiply W and X, and I'll show you in a minute how to do that. Now let's check G. Can we multiply WY? W has 2 columns. Y has 2 rows. Columns go vertically, rows go horizontally. So you could multiply WY. G will not be the answer. G will not be undefined. It would be undefined if you couldn't multiply the two matrices. Let's look at H. YZ. So Y has 3 columns, and Z has 3 rows. So that works. You can multiply these two matrices. Let's look at J. X has 2 columns. And then W, XW for J, W has 2 rows. So the number of columns in the first matrix has to equal the number of rows in the second matrix to be able to multiply two matrices. That works for all for the first answers. So let's try the last answer. K, X, Z. X has 2 columns, but Z has 3 rows. So that is the matrix where you could not multiply them, so the product would be undefined. All right, so that's the big thing. In matrix addition and subtraction, the two matrices have to have the exact same dimensions to be able to add it or subtract it. In matrix multiplication, the number of columns in the first matrix has to equal the number of rows in the second matrix. And the big thing to know, or maybe to help you remember that, because you can imagine a few weeks from now you might be wondering, oh wait, is the number of rows in the first matrix equal columns in the second matrix? I see students mix that up a lot. And the way to remember it, so it's the number of columns in the first matrix. Well, columns starts with C, comes first in the alphabet. Rows, starting with an R, comes second in the alphabet. So the number of columns in the first matrix, C coming first in the alphabet, equals the number of rows in the second matrix, R coming second in the alphabet. So there's sort of an alphabetical order there. Now let me show you how to do matrix multiplication. All right, we're going to do WX here. Let's bring the whiteboard back. All right, so we're going to multiply WX. And the way you do this is the first matrix, you're going to write it like a little bit down to the bottom left. You'll see what I mean in a second. In the second matrix, you're going to write it like 45-degree angle up and to the right, diagonally right above it. And so X is 3794. And your final answer is going to go in that space in between them. And you'll see how everything lines up geometrically. when you're doing matrix multiplication. So the way we get that number in the top left here is we are going to, basically the rows in this first matrix that funnels into it is going to be used along with the column above it that funnels into it to get our number right there, and you'll see what I mean in a second. Okay, so what we do is I call it multiply adding. We multiply the outer numbers by each other, we multiply the inner numbers by each other, and then we add those products. So we do 1 times 3, which is 3, and 2 times 7, which is 14, and we add those numbers up. 3 plus 14 is 17. All right. So here's how we would do the bottom left. We would multiply the outer numbers, 5 and the 3, and multiply the inner numbers, the 8 and the 7, and we add those two up. So, multiply adding. So 5 times 3 is 15, plus 8 times 7, which is 56, comes out to 71. All right, top right, you might be able to do this by now. Multiply the outer numbers, 1 and 9. Multiply the inner numbers, 2 and 4. And we add those up. So 8 plus 9 is 17. And then for the bottom right number, multiply the outer numbers, 5 times 9, which is 45. Multiply the inner numbers, 8 and 4, which is 32, and add them up. 45 plus 32 is 77. So we'll do another one just so you can see it and get enough practice. That was with a 2 by 2. Obviously, rewind the video if you want to go rewatch it and see the steps again. But that was with a 2 by 2, and that works because the number of columns in the first matrix, 2, equals the number of rows in the second matrix, 2. Now, let's see why WY worked. W is 2 by 2. 1, 5, 2, 8. And Y is 2 by 3. So we obviously would not be able to add these two matrices. But we can multiply them because there's 2 rows in the there's 2 columns in the first matrix. There's 2 rows in the second matrix. So the number of columns in the first matrix equals the number of rows in the second matrix. All right. And then our answer is always going to go right in between the 2 matrices like this. So for this top left number, see if you can guess how we're going to get it. Multiply the outer numbers, 1 times 1, multiply the inner numbers, 2 times 4, and add them up. 1 plus 8 is 9. It's middle number. And you see how everything just flows in sort of geometrically, like these 2 numbers are going to go with those 2 numbers to get our answer, which is right there. It all lines up. Okay. Multiply the outer numbers, 1 and 3, plus the product of the inner numbers, 2 and 2. So 3 plus 4 is 7. And this is how you go through that whole matrix. That is matrix multiplication. Now, let's show you why K wouldn't work, why K is undefined. And this will show you really well why the number of columns in the first matrix has to equal the number of rows in the second matrix. So K gives us X, Z. So first matrix, you always write it a little down below and to the left. 3, 7, 9, 4. And the Z, second matrix, always write it above and to the right. 5, 2, 3, 8, 9, 7. And then our answer You go right in between them. So let's say for that top left number, obviously, knowing matrix multiplication well enough by now, you know it's going to be these two numbers and maybe those numbers. That column to give you this number right there where they intersect. But how could you do it? We're going to multiply 3 and 5. Maybe multiply 9 and 3, but what's going to multiply with the 2? It doesn't work. And so you can see that when you line it up, why if the number of columns in the first matrix doesn't equal the number of rows in the second matrix, you won't be able to do it. So I think that explains matrix multiplication quite well. Maybe there's another question we should show you. Just to bring it home. Yeah, we'll do number 57 here. So number 57. First of all, can we multiply these two matrices? Well, there's 2 columns in the first matrix. And guess how many rows are in the second matrix? 2. That means we can multiply these. So let's line it up. First matrix goes a little bit bottom left. Second matrix above and to the right. And for this top number, we're going to take these 2 numbers and those 2 numbers to give us that answer right in the middle. So 2 times 2, outer numbers, plus the product of the inner numbers, negative 5 times negative 1. So we got 4 plus 5, which is 9. You'll notice only one of those answers even has 9 as that top answer. We already know it's E, but just to double check, do the bottom number, negative 3 times 2, which is negative 6, plus 4 times negative 1, which is negative 4. It's going to come out as negative 10, just like answer choice E shows us. So that is how you do matrix multiplication. Yeah, that should be about it. Obviously, you can see question 60 here. Now, you totally know how to do it. You know, they ask which of the following matrix products is not possible. It's going to be whichever one doesn't have the same number of columns in the first matrix as rows in the second matrix. And you go through them all one by one and you figure it out. So that is it. Watch this video again if you need to, and then I think you should start looking forward to seeing matrix questions. It's an intimidating topic at first, and then they're actually really easy once you know how to do them and you notice those basics that I showed you. Thanks, guys.